Good morning. Hope you are all are safe. So, the continuation of the topic. I'm going for the continuation of the topic. Day before yesterday, we did the yesterday we had a brief discussion about the voltage losses as well as copper losses, percentage of power losses. That too with the thing and cost point of view, feeder cost point of view, you have the thing. Total annual cost of the feeder is depends on the annual equivalent of the investment cost and as well as energy cost due to the copper loss as well as to maintain the demand cost incurred to maintain the adequate system capacity to supply I square R losses to the feeder conductor. Okay, these are all are for the when you take summary in India, we will take the cost point of view. We will have the currency is rupee. Okay, these are all are they are taking in terms of dollar per mile. In American standard, in American areas, they are going for the miles. Here, kilometer. So 1 mile is equal to you have a 1.6 kilometers. You can easily convert that, and $1 is equal to 76 rupees. You can easily convert that. Okay, so this is about the cost of that. So when the three things you need to remind, and I am once again saying, okay, to analyze the cost of that particular feeder size purpose, you need to go for the three. One is investment cost of the feeder. Second one is cost of energy lost due to the I square R losses and cost of demand lost. Okay, when the last is there, automatically the distribution companies has to pay. Okay, and as the same way, as a chronological way, the distribution it demands from the transmission it demands from the generation. Like that, you have this particular thing. Okay, this is about the total annual cost of the type. Okay, and annual equipment of investment cost, AIC, investment cost. Individually, I am going for that. AIC idea. AIC purpose, it is a multiple of. AIC is nothing but annual investment cost. All are in the prices. So how we determine the price? How much of charge you need? Okay, how much of fixed rate you have for which rating? You need to see into cost of the installed feeder. If you multiply both, you will know about the investment cost. Okay, cost of the investment feeder into fixed charge rate applicable for the feeder. Okay, this is about the annual investment cost. Next one is AEC. Okay, AIC is over AEC. AEC purpose. AEC is nothing but annual energy cost. Annual energy cost is nothing but it is a multiple of okay. Annual energy cost, how you are going to get is nothing but this particular yeah. So annual energy cost is determined by the, it is a product how it is defined. So this is a due to copper losses in the feeder conductor. Okay, when the copper losses are there, so automatically I square R, how much of current is there, that much of requirement of drop you will have. So how you are going to have is nothing but multiple of the three conductors places 3 into I square R into, okay, how much of power loss you have into cost of energy, okay, depends on the various tariff ratings, and load location factor as mentioned in the previous class into loss factor and loss allocation factor you need to write. Okay, so in a year, why you are going for the annual, okay, in a year you need to consider, so it is multiplied with the 8060. Okay, loss allowance factor into loss factor into load location factor into cost of energy. Okay, this loss allocation factor is depends on the copper losses, that for that purpose 3 into I square R. Okay, 3 into I square R. So this is about the FLL is equal to, we have a difference load location factor of a feeder with uniformly distributed loads can be written as, okay, it is a ratio of, it is a ratio of distance of point on feeder, whether where total feeder load can be assumed to be concentrated for purpose of the calculating I square R divided by L is nothing but the total length of the feeder. When you are going for S amount of distance, that as you need to take. Okay, where you want to fix that particular substation, where you want to fix that particular thing, particular area. Okay, that particular area you need to have. This is about the load location factor, and you know about the loss factor. Loss factor purpose, you have a relationship of 0.3 FLD plus 0.7 FLD square. This is for the urban areas. Okay, when rural areas are there, rural areas are going to have the loss factor is equal to 0.16 into FLD plus 0.84 into FLD square. Okay, this is about the annual energy cost calculation. Okay, so AIC is over. ADC unit. So for that, ADC is nothing but annual demand cost. Okay, demand cost is due to maintenance adequate system, maintain the adequate system capacity to supply the I square. This is about the I square R losses. I square R losses. Sorry, I square R losses in the conductors can be expressed as annual demand cost is equal to, this is about the formula 3 into I square R. 3 into I square R is nothing but the copper losses of the three phase, and load location factor into peak reservative factor, reserve factor we can remind with the FR. Peak reserve responsibility factor is nothing but the FPR. Load location factor is nothing but the FLL. Okay, so and we have a multiples of, again you have a one constant, that constant is represented with the load location factor into cost of the generation system into generation cost, fixed rate of the generation system. See here, CG into IG, CT into IT, CT into IS. This is about the amount you will get. And for this, you have some loss. That loss you need to multiply. And you have the load location factor, you have the peak responsibility factor and reserve factor. So you need to multiply along those three things. Okay, These are the things you need to follow. And the reserve factor. Okay, these are the few things you got it. Cost, you know about that, and the fixed charges purpose. You need to go for the distribution rules. And where is the tariff, you need to know. Okay, the reserve factor is the ratio of total generation capacity to the total load. Okay, the reserve factor is the ratio of the total generation capacity to the total load and losses to be supplied. Okay, the peak responsibility factor is a per unit value of the peak feeder, per unit value of the peak feeder losses that that are coincident with the system peak demand. Depending on the peak demand and peak feeder losses, you will get this peak responsibility factor. Okay, this is about that. Okay, reserve factor is nothing but reserve factor, how much of reserve capacity it is having. Depending on that, you can determine. And in general, we have a relationship, we have a definition for that. It is a ratio of total generation capacity to the total load and losses to be supplied. Losses to be supplied. Okay, and the peak responsibility factor is a per unit value of the peak feeder losses that are coincide with the system peak demand. Okay, all of you remember. Okay, the another one thing, important thing, APC is total cost is equal to AIC, annual incoming factor, annual economic factor, and annual demand factor. These three you add, you will get the total investment cost, TIC. And when the cost levels are increased and decreased randomly, in somewhere cost values are, in somewhere all the feeders, all the roads are taking unity amount of power, in somewhere power is going to have the change. Power is going to have the change. So when those type of things are there, automatically there is a change of the levelized annual cost. Okay, so to levelizing the annual cost purpose, okay, to levelizing the annual cost purpose, in general, the cost of energy and demand, the cost of energy and demand, and even operations and maintenance expenses vary from the year to year during the years as given below. Okay, I'll show you that. Therefore, it becomes necessary to levelize these costs over the expected economic life of the feeder as shown in below. So assume that the costs are occurred discretely at the end of each year. The levelized annual cost of equal amounts can be calculated as the levelized annual cost of equal equal amounts can be calculated as this. Okay, this is a formula only. A is equal to annual cost is equal to, okay, F1 into P divided by F1 whole transpose. Like this type of thing you will have. Okay, and this is about the annual thing. So this is about the why I am going for the F1s and A. A is a annual cost with after the correction. Okay, A is a annual cost after the correction. Before that, levelizing. After the levelizing, this is about the distribution level and equal amount of cost you will have. Before that, you don't have the constant amount of fixed rate. So I'm going for that. Okay, A is a annual levelized factor. Fi is unequal unequal annual cost per year. Okay, and N is the economic life of that particular thing, and I titration. Okay, this is about the I titration. Okay, ith iteration. So that is about the interest rate. Okay, how much you need to pay. Okay, whether you have crossed 2 years, you have not paid any amount. You need to levelize your demand and you need to levelize your annual cost. That for that also we have calculation. Okay, in general, P by F whole to the power of suffix n whole to the power of 1 I will have. Okay, so depending on that 1 plus I will have 1 plus I into whole to the power of n type of thing you will get, and a divided by p whole to the power of I suffix n I will have. So k into I into 1 plus I whole to the power of n divided by 1 plus I whole to the power of n minus 1 you need to have. Okay, this is about the one, two things. P by F, P by F whole to the power of I whole to the power to subs to the n is nothing but payment discount, single payment discount factor. Okay, single payment discount factor is nothing but when you want to pay, if you go for the cost point of view, how much discount you need to give. Through this, how many years you have not paid. For that they will check, and after that that n value is the year. If 1 year is there, one you need to substitute. This cost won't decide the discount percentage you will have. Okay, by this. Okay, a by p whole to the power of I whole to, suffix n is nothing but, okay, a by p whole to the power of I whole to the suffix n is nothing but, this is about the capillary factor. Capillary factor is nothing but, it is a uniform series worth of a presence sum factor. Okay, this is about the uniform series worth of a present sum factor. Okay, this is about that. And see, the single payment discount factor and the capacity recovery factor can be found from, the capacity recovery factor can be found from the compounded interest tables or from the following equations, this equations. Okay, and this is about the economical aspect way and economical aspect way calculation. Okay, so this is about the calculation of the cost. When you go for the economical analysis of the equipment losses. Okay, so always remember, because in the way of plant, in the way of equipment, in the way of energy and capital cost, it increases rapidly. It is costs make it increases more important to evaluate losses of electric equipment. Okay, so where is the loss of that in the power distribution transformer? You have some losses. If you make are existing for, for, for the purpose, okay, something purpose, you need to do the present situation. Okay, for example, nowadays it is not uncommon to find out that a transformer with lower losses but higher initial price tag is less expensive than the one with a higher losses but low initial price, when the total cost over the life of the transformer is considered. Okay, however, in the replacement or replacement decisions purpose. Replacement decisions purpose. How many people are there? I think. In the replacement purpose, okay, in the replacement purpose, or retirement decision purpose, the associate cost savings in operating and maintenance cost in a given life cycle analysis or one life cycle cost study must be greater than the value of the total purchased price of the more efficient replacement transformer. Okay, based on the same concept of engineering and economy. Okay, the carrying the carrying charges of existing equipment did not did not affect affect the retirement decision regardlessly regardlessly the age of the existing unit. Okay, when you are going for the cost calculation and losses calculation, especially you need to minimize the loss and decrease the loss, decrease the cost of that particular thing. Okay, if the investment cost is low, if the investment cost is high, if you got less amount of power, that is a major damage for that. Okay, that's what I am explaining. In other words, the fixed or car carrying, the fixed or carrying of an casting existing equipment must be motorized whether the unit is whether the unit is retired or not. Okay, this is about the economical analysis. And to have the transformer cost purpose, okay, to have the transformer cost purpose, you need to see these factors, these 5 factors. Okay, so first of all, annual cost of the copper losses. After that, the annual cost of the iron losses, copper loss of the existing current, copper loss of the copper loss of the copper cost, sorry, copper cost. So annual cost of the copper losses, annual cost of the core losses, annual cost of the existing current, and annual cost of the regulation, annual cost of the feeder charges, and the first cost of the installed equipment. Okay, these 5, if you know, these 5, if you know, the economical evaluation of the cost of losses in the in an old system, an old transformer or new transformer is going to determine. Okay, so to determine the transformer rating purpose, to determine the transformer rating purpose, or if any site allocation is there, if any extending capacity is having. So because of that, you can have this. Okay, obtain the load and no load losses of the transformer under rated conditions, and determine the original cost of the old transformer and the purpose of the purchase. So determining the original cost of the old transformer and purchase price of the new one, you need to see. Okay, and obtain the carrying charge rate, system capital cost of rate, and energy cost rate for your particular utility. Okay, calculate the transformer carrying charge, and cost of the losses for each transformer, and cost of the losses is equal to the system carrying charges plus energy charge. Okay, these are the things, these are the economical evaluation you need to do. So sir, I have not understanding this one, so how you will explain more? So tell me, I'll tell you one thing. See, I'll give a best example to you. Okay, so when you want to buy a when you want to buy a shirt shirt purpose, shirt or some clothes purpose, what you need to see cost. Okay, to evaluate that economical evaluation of that particular cost purpose. Okay, how which material you will see. Okay, that material history you will see, whether that material is used or not, you will refer. Okay, after that, whether is going to be, and is it feasible to you, is it budgetable to you, you need to see. Like that, you have the economical evaluation of the shelter. Okay, here also economical evaluation of the energy purpose. You need to have the old as well as new substations. Okay, the two transformer. For that, determine the first of all which shop you need to know now, which shop you need to go, what are the things you need to verify. Okay, determine the power ratings for the transformer as well as peak and average system loads. Okay, second one is obtain the load and no load losses for the transformer under rated condition. Okay, third one is demand. determine the determine the determine the original cost original cost original cost of the old transformer and the new purchased cost of the new purchased cost of the new purchase price cost of the new transformer. Okay, this is about one. And obtain the carrying carrying charge rate and system capital cost rate and energy cost rate for your particular utility. Okay, these are the things you need to remember. Okay, and when when all the casts are there, okay, new cast you have, old cast you have. Depending on that, you can compare the cost of each transformer year wise. Okay, compare the total cost per year for each transformer. The total cost is equal to the total cost is equal to the sum of the transformer carrying charges and the cost of the losses. Okay, to determine the transformer cost purpose, okay, you need to compare the total cost per year for each transformer, and it is a sum of the transformer carrying charge plus cost of the losses. Okay, how much transformer is capable, how much transformer is utilizing or which is going to utilize, plus charge of that carrying that particular rating charge plus cost of that particular losses. Okay, these are the things you need to know. And compare the total cost per unit, compare the total cost per unit and the new transformer also. If the cost per unit per year or if the cost per year of the new transformer is less, replacement of the, okay, if one is not working, automatically you are going for the next. Even a next one is also having the less amount of, at the starting you have higher amount of performance, 1 or 2 days, within 1 or 2 days he is not maintaining his health, means automatically you will have a continuous changes of that particular persons. Okay, you have it, the persons are nothing but the transformers. Okay, you have taken 30 kVA 5 MVA transformer, you have taken 3 MVA transformer, so which one you will move? 5 MVA. Okay, 5 MVA. These are the things you need to know. Clear? So are you having any doubt? I'll let you know. Let me also know about that. I'll go for the next topic. Next is only two topics are there, voltage regulation. Why means I am going for the voltage, this is about the voltage drop calculations. So I am going for the voltage regulation. Voltage regulation is nothing but a the percentage voltage drop of a feeder with respect to the. These are the basic definitions. I'll finish within 10 minutes. Don't go out. Most of the people are going out. Don't go out. Okay, I'll finish this class within 10 minutes. I have other work. Okay, please pay attention for that. I'll ask few questions. You need to answer. Okay, so these are the definitions you have. Okay, to have for the okay. Uh, Voltage regulation. Okay, voltage regulation is nothing but the percentage voltage drop of a line with respect to the receiving end is nothing but the percentage of voltage drop with respect to the receiving end is nothing but a voltage regulation. Okay, voltage drop is nothing but a sending end voltage and a receiving end voltage divided by receiving end voltage into 100 you have. Okay, and voltage drop is nothing but the difference between the sending end voltage and receiving end voltages of the line. Okay, this is about the voltage drop. And nominal voltage is nothing but the nominal voltage assigned to the assigned to a line or apparatus or system of a given voltage class. Okay, and next one is rated voltage. Rated voltage is nothing but which performance and characteristic of a of a of a apparatus are referred. Okay, so this is about the nominal voltage is nothing but which is applied assigned to the line or apparatus of a or a system given to the voltage class. Okay, so you have some voltage, but it is operated to it is assigned to the line or apparatus or a system for a given class. Okay, rated voltage is nothing but the voltage at which performance and operating characteristics of a apparatus are referred. Okay, service voltage. Service voltage is nothing but voltage measures at the ends of the service entrance apparatus. Okay, these are the things you need to know. Okay, next one is utilization voltage. Utilization voltage is nothing but these are all are the different voltages things. Okay, utilization voltage is nothing but the voltage measured at the ends of an apparatus. Ends of an apparatus. Base voltage, the reference voltage. Usually in the distribution system 230 or 120. For the 230 or 450, in general, in railways you will use 125. Okay, maximum amount of voltage, largest the largest 5 mm average voltage. 5 mm average voltage at the peak is nothing but this is about the maximum voltage, and minimum voltage is nothing but the smallest 5 mm voltage you will have as a minimum voltage. Voltage spread is nothing but the difference between the maximum and minimum voltages without voltage dips due to the meter starting is nothing but a voltage spread. These are the things you need to know. I will again say the basic definitions. Voltage regulation. Voltage regulation is nothing but the percentage voltage drop of a line. The percentage voltage drop of a line with respect to the voltage receiving end voltage is nothing but percentage of voltage drop. Percentage voltage drop with respect to the receiving end voltage is nothing but a voltage regulation. Percentage of regulation is nothing but Vs minus Vr divided by Vr. What is Vs minus Vr? Vs minus Vr is nothing but a voltage drop. With respect to the, it is the ratio between the voltage drop to the receiving end voltage. Okay, when you are going for the percentage values into 100 you need to get. Into 100 you need to get. As well as voltage drop. Drop is nothing but the difference between the sending end voltage and receiving end voltage is nothing but a voltage drop. Next, nominal voltage. Nominal voltage is nothing but nominal assigned value. Nominal assigned value is nominal assigned value to the line or operators or a system of the given voltage class. Okay, rated voltage. Rated voltage is nothing but the majority of which performance and operating characteristics of the operators. Okay, when the operating characteristics you need to draw, okay, you need to follow some rated voltage. Okay, that voltage you need to follow some voltage. That voltage we will take it as a rated voltage. Okay, and service voltage is you have service voltage purpose, the voltage measured at the ends of the service entrance. The service voltage is nothing but the voltage at the ends of the service entrance operators is nothing but a service voltage. Okay, utilization voltage. Utilization voltage is nothing but voltage measured at the ends of an operator. Base voltage is nothing but it is a reference voltage. Usually for the traction we use 120, 122, 122 to 125 volts. Okay, here we are using AC distribution system. In general 120 volts, in general 230 volts, 450 volts we are using. 230 volts is for the single phase, 450 volts for the three phase. When DC things are there, 120 volts. That's what they are mentioning 120. Okay, and maximum voltage is nothing but at the peak level. Okay, when you see the graph representation of this particular thing, okay, this particular voltage, the largest 5 mm average voltage is nothing but a two peaks. At the edge you have one, and within 5 mm you can draw another two values. That variation we will take it as a the largest 5 mm average value, average voltage value is nothing but the maximum value. And minimum voltage is nothing but the smallest 5 mm voltage. The smallest 5 mm voltage. Voltage spread is nothing but the difference between the maximum and minimum voltage without voltage dips due to the major motor starting. Okay, these are the things you need to remember. Okay, when so quality of the service. So quality of the service is nothing but when the quality will come. Tell me, when the quality will come. I need your answers. Oh, losses. Very nice. There are no losses means you will have that. So quality and voltage standards. So you need to verify the quality for quality equipment or quality analyzer and all those things. Okay. Performance of distribution systems and quality of the service provided are measured in terms of freedom from interruptions, and maintenance of the satisfactory voltage levels. Okay, satisfactory voltage levels are brings the quality of the service and voltage standards. The nominal voltage standards for a majority of the electric utilities in the United States too serve residential and commercial customers are 120 by 240 volts, 3 by single phase system, 240 by 120 volts, 4 by 3 phase delta system, and 208 star 120 volts, 4 by 3 phase Y system, star system, delta star. Okay, 208 star delta star 120 volts, 4 by 3 phase Y system, and You have a 480 star slash 277 star 4 by 3 phase system. Okay, like this you have the thing. This is about the 220 by 380 two wire single phase system. Okay, two wire single phase system. This is about the basic voltage expressed in the 120 volts. Okay, 120 volts voltage is there. Okay, you have plus or minus 5% now. Okay, this is about the increment level and this is about the decrement level. Okay, this is about the increment level and this is about the decrement level. When these things are there, automatically, okay, 127 volts at the starting, it is in the peak value 127 volts on primary at first customer. Okay, 1 volt drop is first transformer. At the first transformer you have 1 volt drop. Okay, and you have the nominal voltage is 120 and rated voltage is 125. Okay, I need the utilization voltage is to be represented. So these are all are the utilization voltages. These are all are the utilization voltages. When it is decreasing, you have the decrement in the particular thing. Okay, you have a decrement in the sending, decrement in the power losses, increment in the power losses, and decrement in the quality of the thing. Okay, when it is moving towards below, automatically system is not in the quality. So always remember these are the things. Okay, always remember these are the things. And this is about the thing. So you have different zones. Okay, 120 by 240 for the single phase, 240 by 120 volts, three phase data. Okay, there are three types of zones. Okay, emergency zone we will consider as a extreme zone, and range A zone, favorable zone to everyone, and tolerable zone is nothing but mediately. Okay, we will not consider those things. Favorable zone is nothing but when 120 by 240, okay, maximum voltage is 126 by 252. Okay, so minimum voltage is 114 by 228. Okay, at the point of utilization 110 by 220. Okay, these are the things you need to go for the calculation. Okay, the favorable zone is preferred zone, and the tolerable zone is somewhat preferable, but the extreme zone is not preferable for anything. Okay, these are the things you need to find. Okay, this is about the voltage drop. So post your roll numbers. This is about your class. Post your roll numbers. Srinivas sir, unmute yourself and speak. If you have any doubt, you can ask also. See, most of the people are not posting their attendance, and you will have a difficulty to analyze also. These things also you need to remind. Thank you everyone. I am closing this window.